All right, grade 11. So this is just me talking you through exercise 12 on the co-ratio, general solution, and complex types. So what I've done is I've already worked it all out. I'm just going to talk you through the process of each. So for A, you've got sine 2 theta equals sine bracket theta minus 30. So because the sine and the sine are the same, straight away you can make the angles equal and apply the general solution. Now for sine, remember, it's going to be the angle plus k360 or 180 minus the angle plus k360. And it's always whatever's on the right-hand side that gets the general solution. The 2 theta on the left stays 2 theta for both. All right, then you have to just get all the thetas to one side and all the numbers to the other side, and you solve. For A, part 2 here, where we're going with the 180 minus, remember, if you've got a 3 theta, you have to divide every number on the right-hand side by that 3 to get theta by itself. So 210 divided by 3 is 70, 360 divided by 3 is 120. But when you move something across, if you move a number across by adding or subtracting, then you only deal with it with the numbers, not the k360. Right, for number C, similar situation. We're working with tan of 3 theta, tan of 2 theta plus 45. So it's tan something equals tan something. So the somethings must be equal to each other, but we add the general solution. Right, then we get theta by itself by bringing the 2 theta across, and we're left with 45 plus k180. K is an element of integers. For D is a situation like the example I did from the textbook, where you've got sine 2 theta, sine theta, but you have this horrible negative in front of the sine. So we undo the negative angle rule and we put it back in the bracket for sine or for tan. For cos, you can't do this. All right, so once you've got sine angle equals positive sine angle, you can drop the signs and use the general solution. Remember, the general solution is the angle on the right plus k360 or 180 minus plus k360. Get all the thetas to one side, all the numbers to the other side, and if you're having to divide here by 3, you're going to divide each bit by 3. But on this side, we're not having to divide, so the 360 stays the same. Right, and please don't forget your k is an element of integers. Moving on to G. G is one where you have to do a co-ratio situation. So it's sine 2 theta is equal to cos. So sine and cos are co-ratios of each other. You can choose whether to change the left or the right. It doesn't matter. I like to change the right. So cos is the same as sine of 90 minus the same angle. And then just make sure you distribute into the brackets here. So 90 plus 50 is 140, and then the theta becomes negative. Then you've got sine, so you can equate the angles, and then you can do your general solution. So it's going to be 2 theta equals angle plus k360, or 2 theta equals 180 minus the angle plus k360. You get all the thetas to one side, the numbers to the other, and you solve. All right, I've just seen that there is, so k is an element of integers. Okay, so as long as you put it somewhere, it doesn't have to be with every step, as long as we can see it. Okay, then for I is one where you, again, have a co-ratio. But here it's better to change the cos to a sine 90 minus. And the way I know I need to change to with a co-ratio is because it's sine of an angle, cos of a different angle. If it was sine and cos of the same bracket, then you can divide by cos and make it a tan of that angle. Just bank this negative over here for a second, Sort out the yellow bracket. Sine 90 minus, you end up simplifying to getting that. And then, because it's negative sine of an angle, we can incorporate that negative back in and bring that negative to both bits within the bracket. Okay, so then we end up with sine bracket equals sine bracket. Because it's sine and sine, not sine and negative sine, you can then drop the signs and use the general solution. All right, get everything over to one side and then solve. Okay, then I didn't ask you to do these questions, but I've just put them in. Again, it's just some extra ones. In this case, for question B, you have to change both sides. And the reason for that is because you have this negative cos, and you can't use the little negative angle trick with cos. You can only do it with the sine, where you are going to bring that negative into the bracket like that. But then your other side would still be a cos, so we change the left-hand side also to a sine 90 minus, and eventually it ends up getting you the sine bracket equals sine bracket, and then you can drop the signs and equate and do the general solution. Okay, so question B is just a little bit tricky using the method that we use in class. Using the textbook method, this one happens to be a little bit easier, but we don't want to have to learn a whole new method just for one question. So we'd rather do a double co-ratio. And just remember, the only way that you can get rid of this negative in front of a cos situation there, you're not allowed to bring it into the bracket. It doesn't work. You have to change it to a sine and then bring the negative into a bracket. So if you're stuck with a cos on the other side, do a double co-ratio. Okay, then for F is tan bracket equals negative tan bracket. Now tan is like sine. We can bring that negative back into the angle. So it's just cos that you can't do that for. And then you have tan equals tan, positive and positive, bracket will equal bracket, plus your general solution, plus K180. All right, then for E is quite easy because it's cos. So all we need to do is drop the coses, make them equal, do our general solution. Remember, for cos, it's going to be plus minus. So I've split it into the positive one and then into the negative one. Okay, don't forget you need to distribute that negative in and then take all the angles to one side and take the A's to the other side and then solve. All right, then for H is cos 3 alpha equals sine 2 alpha plus 45. So because these angles are not the same, we have to change one using a co-ratio. So I've changed the sine to a cos 90 minus the angle. Distribute that negative in, and then you get down to cos, so you can make their angles equal. For cos, don't forget it's plus minus, and then your plus K360. I've separated it into the positive version of the bracket and the negative version of the bracket. And then we solve. Okay, the last one is another sort of basic one where you have cos equals sine of different angles. Again, if they were the same angle, you could change it to a tan. So instead, we have to change it to a co-ratio. I've changed my sine to cos 90 minus the angle, distribute in the negative, and then we get to cos, and so we can do general solution plus minus of that angle. So this is the positive version of that bracket. This is the negative version of that bracket. I've distributed straight away already. Okay. Then because for the first part of the general solution, we end up with 0 theta. It means there's no solution. So the only answer is negative 7,5 degrees plus K180. All right, grade 11s, that's it. Again, a little bit later, I'll post up the last video. It won't be long. It's just using this general solution to kind of solve one quick thing that's normally for like 1 or 2 marks in a test if they even ask it. So this is the last sort of main bit, and then after that, the part 7 video, I will then do a video on trig functions, and then we can get trig completely out of the way. All right, I hope this made sense.